So we'll continue. Yeah, it's okay. So share. Okay, so anyways, we were here. I was showing you not cards or not when you're not trying to find the probability of something. You subtract. You take the probability of that item and then you subtract it from 1. So any questions with that?
No, but I had a question about number 14
Oh,
and,
okay.
and also number 20.
So you're okay with number 5?
No, I haven't looked at number 5.
All right, let's do 5 first.
Okay.
Because 14. All right. Yeah, let's
And number 8 also.
all right, let's go ahead and go in order. That way we're not bouncing all around. We got 3 fair coins that are tossed. Find the probability of getting exactly 2 tails. So when you're trying to find the exact probability of something, you've got 3 coins. And we want to find 2 tails. The probability of getting 2 tails. Okay, so you're going to use binomial probability, which is a combination of n taken x at a time times the probability of p is successes, q is failures. So you're trying to find the probability of success times the probability of failure, which in that exponent is these two n minus x. So you got n is 3 total. N is going to be your total, which is 3 coins. X is 2 tails. So X is 2. Probability of success getting 2 tails. Well, a coin has either a heads or tails in it. So the probability of getting a heads, or tails rather, in this case, tails, is 1 over 2. So probability of success is 1 over 2. So P is 1 over 2. The probability of failure, which failure doesn't necessarily mean a bad thing, it just means you're not getting heads, is Q. And Q is equivalent to 1 minus whatever P is. So since P is 1/2, this would be 1. Let me write it over here. This would be 1 minus whatever P is 1/2. Well, get a common denominator, just change the 1 to 2 over 2 so that you've got the same denominator, because 2 over 2 is the same thing as 1, and you get 1/2 there as well. So n is 3, x is 2, p is 1/2, and q is also 1/2. So to put it in our binomial probability equation, we would write this as n combination. N we said was 3. Let me use the other one. This one's drying out. Combination of 3 taken 2 at a time, because that's what x is. X is 2. P, we said that's 1/2. And so this x is going to be the same as that x, so this exponent is 2. And Q, we said that is also 1/2, right? Here. So we put that there. And so now this will be 3 minus 2, right? Whatever. It's basically the exponent for failure is just the difference of the total and x. So 3 minus 2 is 1. Okay. So we put that in our calculator. Okay. So I need to dim this down a little bit so you can see it on the calculator. Okay. So move this over here. So now you're going to take 3, you put 3 in. And then you go to math, right here. Come on. Math. And, come on. There we go. And you want to go here to probability. You click that, and you go to 3, combination. And is there a A there? I don't want that A. All right, let's start over. 3, and then math, and then probability 3. Okay, and then you put 2 in. It's a combination of 3 taken 2 at a time, and then you open 1 over 2, close it. Exponent is squared, so we just hit the x square button. And then 1/2 again, or you could just put 0.5. And since that's 1, since this exponent is 1, we don't have to put anything up here for our exponent. So we've got a combination of 3 taken 2 at a time. Probability of success is 1/2 squared. Probability of failure is 1/2 to the first power. Hit enter. And we get 0.375. But we want a fraction. So the way we can do that is we can go to math, okay, and then go to number. And maybe it's, here it is, math, and then fraction. So you see answer, right? That's the last answer you had is that. And you want to convert it from a decimal to a fraction. Hit enter, and there's your fraction. So your answer is 3 over 8. Okay? Questions with that?
No, sir.
All right, good. So we'll just set that aside. Bring that up a little bit so we can see that better. Okay, so that's number 5. So you're good with 6 and 7?
Over.
You can go over 6?
Yeah.
Okay, I'm going to show you a trick here in how to determine the number of days in each month. And it's kind of a silly trick, but it works. You take your knuckles, right?
Mm-hmm.
The knuckle, each knuckle is 31 days. The valley, right, is either 30 or 28. So if you start with, first one here is January, that's 31 days. February is down in the valley, that's 28. March is in the knuckle, that's 31. April is 30. May is 31. June is 30. July is 31.
Mm-hmm.
Go back over to the first one. August is also 31. September is 30. October is 31. November is 30. December is 31. Kind of a silly thing, but it works. So we've determined that May has 31 days in it, right? So the probability is we want to know what's the probability of a person having, let's see, a person randomly selected, find the probability that their birthday is in May. So the probability birthday is in May is going to be the number of days in May over the number of days in the year.
Mm-hmm.
And so we don't count the leap year. Okay. So
Okay.
May has 31 days, the 365 days in a year, and that's your probability for randomly selecting somebody with a birthday in May. Okay?
Yes, sir.
Okay. Number 7. Any questions with 7?
Um,
Odds in favor
uh,
of drawing a 3. We got 5 cards. 1, 2, 3, 4, 5.
mm,
There's only one 3, right?
yes, sir.
So with odds, you have, with odds, you've got number of 3s to number that is not a 3. We'll put a bar over for not 3. Well, how many 3s do we got? How many 3s do we have in these cards? Just one, right? We only have one 3. So that's 1. Well, how many are not 3s? Well, one's not a 3.
Yeah,
2,
4 of them.
4, right? So that's your odds that you'll select a 3. Odds in favor. So normally they'll just say odds, but if they just ask for odds, that means odds in favor. If they say odds against, they'll tell you odds against. And all you do with odds against is you take the odds in favor and you flip it. So odds against selecting a 3 is 4 to 1. Okay?
Okay.
Okay. Um, so number 8, you needed to see 8.
Yes, sir.
Okay, Mendel found no dominance in snapdragons with respect to red white flower. When pure red and pure white parents are crossed, the resulting combination produces second generation offspring, pink flowers. Suppose one of these second generation pink is crossed with a pure white. What is the probability that the resulting snapdragon will have white flowers? So 2 uppercase is pure red, 2 lowercase is pure R. So what we're saying here is,
I have a question. Is that where you make the little square and then you try to
yes,
like connect them?
yeah,
Okay, I understand that now.
yeah, it's a Punnett, yeah, that's
Yeah.
called a Punnett square. Yeah, that's it. So did you still need to see it, or are you okay? Well, let's go ahead and do it. So you got one parent is uppercase. So, okay, you got second generation. So basically, the first part is just explaining it. Suppose one of the second generation pink, so we've got pink, right? Which is uppercase R, lowercase r. So this is pink. Is crossed with a white. Okay. What is the probability that the resulting snapdragon will have white flowers? So pure white is 2 lowercase r's. Okay. So we have lowercase, uppercase, right?
Yeah.
So that's a pink. And here is lowercase, lowercase, right? Okay, you with me?
Yes, sir.
And then we got lowercase and uppercase again. So we got another pink and lowercase and lowercase. So we've got a total of 4. So we're looking at number of white over the total. Okay, for probability of getting pure white. Well, we've got 2 white, right, over a total of 4.
Mm-hmm.
So your probability is 1/2
So 50%.
with a pink and a white. Okay,
Okay.
and that's all. That's all there's to that. Okay, 9 or 10. Any questions with that? We good?
No, sir. Yeah, I'm good on 9 and 10.
Okay. Um, Faraday's, so 11, Faraday's roll was the probability of rolling a 3 or a 5. Any questions with 11 or 12?
Uh,
Yeah? Let's go.
uh, we can go over that.
Okay. All right. Now, let's go back to 9 and 10 for a minute. Decide whether or not the events are mutually exclusive. So, mutually exclusive means there's nothing in common between the two events. In other words, you don't have anything where there's an overlap. Okay. So, for example, um, being a male and being a nurse. Well, is there such thing as being a male nurse? Yeah, you can be a male nurse, right? So that these two, male and a nurse, are not mutually exclusive because you can have both. Whereas being a teenager and being a senator, well, the minimum age is what, 21 to be a senator. So you can't be a teenager and a senator. So those are mutually exclusive. So that would be a yes. Okay. Now, let's say, so mutually exclusive, or we'll just call it ME for mutually exclusive. Okay. So to be mutually exclusive, probability of event A plus probability of event B. And that's all you have to do there is just add the two. But if it's not mutually exclusive, and we'll put a bar over it for not mutually exclusive. In other words, you got an overlap or something that's in common. Then you have to add the two, probability of, we'll call it X plus probability of event Y minus what's common, X and Y. Okay, so let's look at number 11 again. A fair die is rolled. What is the probability of rolling a 3 or a 5? So it helps to write out the sample space for a dice. Okay. Excuse me. We've got 1, 2, 3, 4, 5, 6. Okay. You can roll the dice and roll a 1 or a 2 or a 3 or 4 or 5 or 6. So we're saying, what is the probability of rolling a 3 or a 5? So we're saying, okay, what is the probability of rolling a 3 or a 5? So there's no overlap there. So we can say the probability of a 3 plus the probability of a 5. Well, probability of a 3, there's only one 3, so that's 1 over a total of 6. And so the probability of 5, well, there's only one 5 over a total of 6 numbers in a dice. So the probability of rolling a 3 or a 5 is 2 over 6 or 1/3. Okay? We good?
Yes, sir.
Okay. Now, a fair die is rolled. What is the probability of rolling an odd number or a number less than 3? Okay? So let's look at our sample space again. Odd numbers are 1, 3, and 5, right?
Mhm.
But the numbers less than 3 are 1 and 2. So do we have anything that's both odd and a number less than 3?
No. Yes. No.
What about 1?
I mean, oh yeah, yes.
1's odd, right? And it's a number less than 3. So odd or number less than 3 are not mutually exclusive. So the probability of odd plus probability of a number less than 3, but you have to subtract the probability of odd and a number less than 3. Okay, well, how many odds are there?
There are 3 odd numbers.
3. Yeah, so that would be 3 over a total of how many numbers on a dice? 6, right. So that's 3 over 6 odd numbers on a dice. How many numbers are less than 3 on a dice?
3.
Oh, that are less than 3.
Oh, just 1.
Just 1 and 2, right? So it'd be 2 over a total of 6 minus the probability of odd and a number less than 3. Well, how many numbers are odd and less than 3?
1 and 2.
It's just 1, right?
Yeah.
Well, 2's not odd, right?
No, sir.
2's less than 3, but it's not odd. But 1 is odd and it's less than 3. So it's just 1. Okay?
Yeah.
So that's 5 minus 1 is 4 over 6 or 2 over 3. Okay?
Uh-huh.
All right. So with or, you add. We're not doing and. We're not doing multiplication and probably just adding. So with adding, you have to be careful by looking at whether it's odd. I mean, whether it's mutually exclusive or not. Okay. So it helps to write out the sample space like what we did to see if it's mutually exclusive or not. Okay. All right. So number 13. A card is drawn at random from a well-shuffled deck of 52 cards. What is the probability of drawing a face card or a 4? Well, let's look at the sample space on that. Okay, here we have let's use red for the red cards. We've got hearts and diamonds. And that's ace, 2, 3, 4, 5, jack, queen, king. Okay. And diamonds, same thing. Ace, 2, and that goes on. Jack, queen, king. Okay. And we also have spades and clubs. And that's, you got ace of spades and 2 spades and so on. Jack of spades, queen, king of spades. And clubs, same thing. Ace, 2, jack, queen, king. Okay? Each suit has 13. There's 13 cards in each suit. Altogether, there's 52 cards. Okay? We want to know what is the probability of drawing a face card or a 4. We want probability of a face card or a 4. Okay? Well, here's 4, right? 4, 4, 4, 4, right? So here's 4s, and here are all the face cards. Okay, so if they overlap, okay, if there's an overlap, then they're not mutually exclusive. If they run where there's no overlap, like this or like what we've got, those are mutually exclusive. So we just add them up. Okay. So we just find the probability of how many, probability of 4s plus probability of a face card. And we don't have to subtract because we don't have an overlap, right? There's nothing that we get both. There's no such thing as a 4 that's a face card, right? So we don't have to subtract here. So how many 4s are in the deck?
4.
4. Yeah. There's 4 4s, and the total of cards is what?
52.
52, right. Plus, well, there's 3 jack, queen, king. There's 3 face cards in each suit, and there's 4 suits. So how many face cards are in the deck?
Wait, what was the question?
How many face cards? We want the probability of face cards. So we need the number of face cards over the total.
4.
Well, there's jack, queen, king of hearts, jack, queen, queen of diamonds, jack, queen, king of spades, jack, queen, king of clubs, right? So how many, if there's 3 in each suit and there's 4 suits of face cards, how many face cards are there?
12.
3 times 4 is
12.
12, right? There's 12 face cards. So there's 12 face cards over 52 total. So now we just add them up. 4 plus 12 is 16 over 52. And we know 4 goes into both because there's 4 suits in the deck. So we know 4 goes into 52. And that's 13. 4 goes into 16. Well, 4 times 4 is 16, right? So our probability of drawing either a 4 or a face card is 4 over 13. Okay? And that's our answer. Okay, questions with that?
Sorry.
All right. Okay, number 14. Any questions with that? We okay?
Yeah.
Okay. 15 is the same as one on the previous page. That one got repeated. 16 is the binomial probability again. So that's where you have to use the combination with P and Q. Do you need to see that one?
No, sir.
Okay. 17 is also, let's see, 17. What is the probability of 17 rolling on the third die roll 3 sixes? Again, that's binomial probability. Okay. We need to see that one. We'll go ahead and do that one. Okay. So again, it helps to write the equation for binomial probability.
Mhm.
Okay, so we'll write it. I like to always go ahead and write that. So a combination of n taken x at a time, probability of success to the x power, probability of failure is q, n minus x. Okay, get that in focus. There we go. All right. So we've got 17 rolls, and on a fair dice showing 3 sixes. And 3 sixes. So if we roll the dice 17 times, we want to know how many times do we roll a 6. Okay. So I like to write the components to the equation off to the side. N, X, probability of success, probability of failure. Okay. N, there's 17 rolls, so N is 17. X, we want to know what's the probability of getting 3 sixes. So X is 3. Probability of rolling a 6, well, what's the probability of rolling a 6? Number of sixes over the total. Well, how many sixes are there on a dice? Yeah, 1. So it's 1 over 6, right? So the probability of failure, Q, is 1 minus P. So that's, since P is 1 over 6, we're going to change 1 to 6 over 6 so that we get a common denominator. So 6 minus 1 is 5 over 6. Okay? So now we're ready to put these into our binomial probability equation. So n, we said, was 17. Combination of 17 taken 3 at a time. Probability of success, p, we said, is 1 over 6.
Mhm.
Whatever this number is, that's what you put for your exponent for p. Q, we said that was 5 over 6, right? So this is 5 over 6. And this will be 17 minus 3, right? N minus x. So this will be a combination of 17 taken 3 at a time for 1 over 6 to the third, 5 over 6. 17 minus 3 is 14. Okay?
Mhm.
All right, so let's take a look and see what that looks like on the calculator. Okay, so get this, adjust this so you can see it better. All right, so we put in the 17 first. Well, you can't really see my finger too well. Let me bring it up a little bit. There, that's better. Okay, 17, right? Put that in first. Okay, and then go to math and probability, pure, and then combination is 3, and you should see a C there, right? Combination of 17 taken 3 at a time. Open the parentheses, put 1 over 6. 1 divided by 6. It'll show 1 divided by 6, but it's the same as 1 over 6. And then we put exponent to the third power. But it's up here, it's superscript, right? Way up here at the top. So you have to hit the right arrow to get out of the exponent feature. And then open parentheses, 5 over 6. Close that. And that's going to be to the 14th power. So we raise that and put 14 in there. I like to go ahead and get out of that exponent. So I hit the right arrow. So we got 17 taken 3 at a time times 1 over 6 to the third times 5 over 6 to the 14th. We just hit enter and we get 0.2452. And let's see, how do they want the answer? With fair die, we'll show 3 6s. So, okay, they just want it left as a decimal. So notice, now you can, if you go to mode, okay, and go to display, decimal number format, normal mode, okay, if we were in normal mode, and normally the calculator is in normal mode, you're going to get all these decimals, right? Well, you can round it off by going to mode, go to decimal, and then go to fixed mode. And you can see the decimal point. You can see how this bar is sliding. See, this is 2 decimal places, 3 decimal places, 4 decimal places. You see that? So you can set the calculator to round it off for you at 4 decimal places. So, and that's what it did here. Okay. Now you don't have to do that. It's just something I like to show people to kind of get more familiar with the calculator. Okay. Any questions there?
No, sir.
All right, good. Bring that up a little bit so we can see it better. Alrighty. Let's go on to the next one. Okay, 18. A contractor is considering a sale that promises a profit of $22,000 with a probability of 0.7, or a loss due to bad weather, and he would lose $3,000 with a probability of 0.3. What is the expected profit? Okay, so this goes to expected value. And expected value, we'll use EV for expected value, is the number of items that you're working with times the probability. Okay? So if you're working with multiple items, then the expected value would be item 1 times its probability plus item 2 times its probability, and so on. And you just keep going, okay, till you get to the end. Okay. Now, if there's a loss, your loss would be a minus. Okay. So in this case, our probability, our X in this case would be 22,000. Okay. So our expected profit we use expected profit. It's the same thing as expected value because we're talking about money, right? If it was winnings, then it'd be expected winnings and so on. So we're expecting to get 22,000, right? 22,000. Oops, 22,000 times the probability that we will get to 22,000 is 0.7. Plus, if it rains, we don't get anything, right? Like you see these construction workers out here working on our science building, right? If it rains, especially with this outside building that they're doing, they can't work, so they lose money, right? So that would be a loss. So you have to subtract 3,000. So plus a negative, right, for 3,000. And that probability is 0.3. Okay? You with me?
Yes, sir.
Okay. So let's go to our calculator and dim this a little bit so you can see it. All right. So we clear that, and you're going to put 22,000. All right. Times 0.7. And then you don't have to put plus negative, right? You can just hit minus 3,000 times 0.3. And you hit enter. And over a certain number of days, we get some, profit of 22,000. Might get some of them, it might be a loss of 3,000. But overall, over a long period of time, our average profit is going to be, our expected profit is going to be $14,500. So let's see. Yeah, 14,500.
Mm-hmm.
And that's our answer. Okay? Questions there. So that's expected value. If you're having some trouble with that, you may want to go back over the last lesson on this chapter is expected value. 11 point, that's 11.5. 11.4 was binomial probability. Okay? That was the problem before that. Okay. Any questions with that?
Okay.
Okay, number 19, suppose a charitable organization decides to raise money by raffling a trip worth $500. If 3,000 tickets are sold at $1 each, find the expected net winnings for a person who buys one ticket. Okay, now I did an example exactly like that in the lesson. Okay, so did we need to go over that?
No, sir.
Okay. If you have any problems with it, go back over 11.5. All right.
Okay.
And I give the exact same problem. Okay, number 20. Basically, all we're doing is we're just taking the number of offspring times its probability. So 0 plus 0.31 plus 1 times 0.21 plus 2 times 0.19, and so on. Okay, so we're getting back to this. All right, so that would be 0 times 0.31 plus 1. So in other words, having no offsprings at all, the probability of that is 0.31. To have one offspring is 0.21. To have two offsprings is 0.19, and so on. So one offspring is 0.21 plus two offsprings is 0.19 plus 3 offsprings is 0.17 plus 4. As you get further down there, then the probability gets smaller. Then you just calculate that out. Okay? Any questions? So your final answer is going to be 1.58. Okay?
Okay.
Alrighty, and that's the review. Alrighty, so I would go back over the review again one more time before you take the test. And I found that students that do the review a second time do better. Okay? And I'll have this video posted so you can look at this as well. All right? And
All right.
because we got interrupted, it'll be in 2 parts.
Okay.
Part 1 and part 2, but you get the idea. Alrighty. Any other questions?
No, sir.
Okay. I'll see if I can get some of the other, if there's any other videos, I'll go ahead and post those too. All right.
All right. Thank you so much.
Okay, you're welcome. And I'll be in the process of grading the essays as well. So if you haven't submitted any of them, I'm not going to give you. I won't.
I'm gonna just go on try to use Firefox tonight and try to like re-upload all my work.
Okay.
And try to resubmit all my work because, like I said, on my end, it's giving me grades, but it's still a 0.
Oh, really?
Like, yeah, so it's like so it's like I'm great, like I'm doing the work, but it's not showing up on y'all end. So, like I said, this has been happening with all my classes. So I'm gonna just try to use Firefox or Google Chrome tonight.
So yeah, you know what? I'll have to put that in the syllabus. That Safari, is that what you're using?
Yeah, because I'm using a MacBook Air, and it's the Safari app that Apple uses.
Yeah.
That's what's wrong.
Yeah, I think I'll put it that Safari doesn't work well on Blackboard because you're not the first one that's had that problem with Safari.
Yeah, and Miss Dr. Bowens and Dr. Reed, they're giving me a little bit more time because it's like I said, I'm doing the work, submitting the work, but when y'all go and grade it, it's like y'all can't see it on y'all end. So it's like, yeah.
Yeah. So if you what I'll do is with the essays, if you go ahead and submit your essays, I won't count them as being late.
Okay.
Yeah. In fact, I won't count any of your tests or quizzes being late. Okay. But you'll need it. I mean, you only get like maybe one. You may be able to submit it more than once, but I'll count the last one. Okay.
So like as soon as I get off of work and get home, that's literally what I'm gonna be doing tonight, and I'm off for the rest of the week because I'm going on vacation. So that's really what I'm gonna be doing.
Okay, that works. Now you can keep going too. You can go all the way to the end. You take the final and everything, and you can be done early. You can go ahead and finish early.
Okay.
All right, even though the final's not until, let me see. The final's not until like the week of the 3rd, but you can go ahead and if you can get done before then, that's fine. You're done.
Okay.
Yeah. Just let me know so I don't mark you absent on the attendance.
Okay.
Yeah, that way you'll be exempt for the rest of the semester once you're finished and you send me the email and I got to check it and say, okay, yep, you got everything done, you're good to go, and you're exempt from any other attendance.
Okay. All right. Thank you so much, and I'm gonna try to do better of joining your Zoom calls, honestly. But like you said, I'm gonna
Alrighty.
try to catch up on not catch up, but like turn in all my work
Right.
and see where it goes from there.
Okay. Sounds good. Alrighty. Have a good day.
You too.
Thank you.